Welcome to Programming in Modern C++. We are starting week 6 with module 26. In the previous week, we took a look at the inheritance mechanism of C++, which is the way to realize is a relationship or a hierarchy of generalization, specialization in C++. So, we have considered different aspects of that, how to define the hierarchy, what happens to the objects when they are constructed, they are destructed, their lifetime, particularly taken look at method overriding and method overloading processes and so on. So, this gives a solid foundation to the object oriented second object oriented aspect of C++, which is about inheritance beyond the encapsulation that we had seen earlier. In this week, starting with the current module, we will primarily take a look at polymorphism, or as it is said, static and dynamic binding on a hierarchy or even outside of that. This will be the third major aspect of object oriented programming, which gives the foundation to the efficient use of C++ as an object oriented language. Starting with that, we will first take a look at what is typecasting. What is the difference between implicit and explicit casting, how casting can work on a hierarchy, and we will introduce the notions of upcast and downcast on a hierarchy. So, this is the outline which will be available on the left panel as usual. So, talking about typecasting, I am sure all of you know typecasting from C in a very I should say compact way. So, casting is performed when a value or variable of one type is used in place of some other type. So, when we want to do that, then naturally we need to convert an expression in general, which could be a simple value, a literal, a variable, or an expression involving operators, which is of one type, and we take it to another type, we say that is typecasting. So, here is an example, there is an int variable and there is a double variable initialized, and we are trying to define a result which is the division of d by I, that is a double value by an integer value. You know, in C this is called mixed mode operation. We will not use those terms frequently now, because we will generalize to a much bigger context. So, the basic issue here is this is double and this is integer. Since the division in the system can either be of integer type, that is an integer divided by another integer, or of double type, floating point type, where a floating point value is divided by another floating point value. This is what turns out to be, as we say, is a mixed mode. That is, it involves a floating point value with an integer value. So, what we will need to do, what the compiler needs to do, since it cannot do this division, it will have to convert this integer value to double. Now, obviously, we will ask the question as to why I is converted to double for the division, why not d is converted to int for the division. That is to preserve as much of information as possible, and we will look at those rules later. Now, as you can see, as you have known in the C language, that such conversions are implicit in the sense that you did not have to say that you convert the integer to the double, the mixed mode automatically supports that. So, that brings us to the first basic notion about casting, that it can be implicit or it can be explicit. Consider a few examples. In the context of the above definition, suppose I try to assign I to D, that is an integer to a double. This is implicit, because if I assign I to D, the value of I, which is an integer, will have to be converted to the value in a double format. So, if the value of I is 3, it will have to become 3.0, it has to take the format of the floating point number and so on, and this is allowed implicitly. I am not explicitly saying that, the compiler knows that the int is being assigned to a double and it will allow that. I can do the reverse also, assigning D to I, that is trying to convert double to int. This also implicitly be converted, but the compiler will give a warning. GCC will give a warning, because when you convert an integer, a double value to an integer, you may not have a correct representation. For example, if you convert 2.5 to integer, it will possibly become 2, right. So, you are losing information. So, there is possible loss of data. The compiler allows you, but not silently, it will give you a warning. In contrast, you can do these things if you do not want the compiler to advise you, or if you really know what you are doing, then you can write explicitly that I want the integer I to be converted to double, and this is the type of casting that you have seen in C, or you can do the reverse. In either case, the compiler will allow it and will allow it silently, because it knows that as a programmer you know what you are doing. That is the basic assumption. And so, when we write like this, where inside this pair of parentheses there is a type given, it is considered that it is an instruction to the compiler to convert the value from the given type, which can be obtained from I or from D, this is int or this is double, to the type that you have specified, and this is known as a cast operator. This is more specifically known as C style casting. So, we will in C++, this will get into lot more of depth. So, what we will do, we will look at the different casting rules in certain groups. First, we will look at the casting for the built-in types, then we will look at casting for unrelated types including classes. C++ deals primarily with classes. And then we will talk about what happens to casting when we have a inheritance hierarchy, what happens at the compile time and what can happen at the runtime. So, there is casting all over. So, these different aspects are what you will see in the next couple of slides. Now, before we proceed further, I would just like to highlight the basic differences between implicit and explicit casting. You may find this you may want to revisit this slide after you have understood the casting well. So, in implicit casting, as you have seen, it is done automatically by the compiler, but explicit casting has to be done programmatically by the developer. In implicit casting, there is no loss of data if you are promoting, that is taking a smaller sized data type to a bigger sized data type, and compiler will be silent. But if you do the reverse, as you have seen, so for the case of int to double, compiler was silent. If you do the reverse, if you do a demotion, that is from a bigger size to a smaller size, naturally in the smaller size data type you will not be able to fit all the information. When you convert a double to an int, the compiler will issue a warning. For explicit casting, there may or may not be loss of data. Int to double, possibly there will not be loss of data. Double to int, there will be loss of data in most cases. Compiler will always be silent, because it knows that the developer is knowingly doing this. Implicit casting does not throw an exception. You still have not, we have not done exceptions. So, you will see that more when we do that, and therefore, it is type safe, whereas explicit casting may throw exception. In implicit casting, as you have seen, there is nothing specific that you are writing down. So, there is no specific syntax, but for explicit casting it requires cast operator, either C style as we have just discussed, or as we will see that there are 4 specific operators provided in C++, const cast, static cast, dynamic cast and reinterpret cast, which allow us to do a casting in the proper semantic manner in any of the between any 2 different types. It will let you do the casting, or will through exception, error, compile time error and so on to let you know what you are actually doing and whether it is acceptable. Implicit casting, it is advisable that you avoid, because it cannot be easily figured out from the program. You will have to really think what is happening, like when we do d divided by I, it is not written, nothing is written. So, if you avoid that, do explicit casting when you need to do, then anybody reading the program would find it easier to follow. And even in that, I would advise, and that is what the community strongly says, that in C++ avoid C style casting, do not do it unless it is absolutely necessary, but such situations will not occur. If you are using C++ casting properly, always use C++ style casting. Implicit casting is possible only at the static time, compile time. As we will see, explicit casting can be both at the static as well as dynamic time, and implicit casting may be disallowed for user defined types. There are ways to do that, we will see that, but it cannot be disallowed for the built in types. For explicit casting, you can define the way you want the casting to happen for the user defined types. So, these are kind of the basic differences between the casting, 2 forms of casting that we have. So, let us move on to the discussing the rules for the built in type. This is the example you have already seen. We have seen this, these are implicit casting, these are explicit casting, but not everything can be explicitly cast either. For example, I have a pointer p which is a pointer to a double. Now, if I want to assign that to an integer, I will get an error, there will be an error, because a pointer is not implicitly allowed to be treated as an integer, but explicitly I will be able to do this kind of a conversion. Why we at all will do that is something we will discuss subsequently, but this is the basic rules of casting in terms of the built in types. Now, built in types, if you consider, then there are primarily, you will see there are primarily 2 kinds of types. One is numerical types, which are all of these, some of which are integral, like this, these are integral, whereas float, double, long double, these are of floating point type. Now, casting is safe if you do promotion, that is, if you take a smaller sized data type to a larger sized data type. So, this arrow chain shows what is the chain of promotion that is safe, right. So, this promotion implicitly or explicitly among numerical types will usually be safe. The casting of built in type does not invoke any conversion function. You are converting 2.5 to say 2, or you are converting 3 to 3.0. So, naturally there are bit patterns which has to change, but it does not happen through invocation of a function, which we will subsequently see. It just reinterprets kind of things whatever is written here as a double 2.5, it just thinks that it is integer 2 and creates the bit pattern for that. Casting will be unsafe if you do demotion. For example, if you take a double into an int, smaller size data type, it will be naturally unsafe. We have already seen examples therein. Now, the other type which is dominant as a built-in type is a pointer type, pointed to different types of, let us say we restrict to only pointers to numerical types. So, implicit casting is not allowed, you cannot have implicit casting. So, if you have a integer pointer here and a double pointer here, then you are not allowed to cast either into the other, right. Mind you, the integer or double can directly be cast, but their pointers are not implicitly castable. You will have to cast with an explicit intention of the cast operator. Any pointer can be implicitly cast to void star. Here I have a pointer void star, which means that it is a pointer, but not known to which type. You can convert any pointer, for example, p pointer to integer to void star implicitly. Compiler will not complain, because when you do that, you are not making any additional assumption. You knew that this is pointing to an integer, you are just choosing to forget that. But if you try to do the reverse, that is void star to int star, the compiler will give an error, because obviously by saying that r is void star, you are saying that it points to something I do not know, right. So, you cannot implicitly say convert it to integer, saying that it is now pointing to an integer. If you have to do that, then you will have to explicitly say that, right. So, this is the second main point. The third which might arise to your mind is we have often used array and pointer in term, one in the place of the other. You must have seen this in C quite often. This is called array pointer duality, particularly important for multidimensional arrays. So, this conversion is not actually a typecasting. Please keep that in mind. It is just a syntactic form of writing the same intended expression in multiple syntax. For example, if I have an array A 10 of integers and I have an integer pointer p, then I can assign A to p, because it is a address, the base address of the array, I can assign that to p, and then I can use pi, ai, star p plus I, star a plus I, all these are equivalent of accessing the ith element, right. So, this is not a case of conversion. If you try to do the reverse, if you try to assign a pointer to the array base address, you will get some kind of an error like this. The basic reason that you get the error is the base address of an array is a constant. It is a constant pointer, right. So, we will come to the role of constness in this, but simply you can remember that you cannot change the base address of an array. So, you cannot assign a pointer of the same type to the base address, and you will get an error. Now, this is about the conversion between pointer types. Now, if you want to do a conversion between pointer type and numerical type, the basic rule, it is not allowed. But there are situations where explicit casting between pointer and an integral type, I mean not a floating point type, but an integral type like int, short int, long and those kind of are the common practice, and actually is the only way to do certain tasks like serialization and deserialization. You may not be familiar with these terms. What does it mean is, when you store a file, save a file, like you are editing a document in Word, and you say you do Control S and save the file, you are actually serializing from an in-memory data structure of the document to a linear sequential file in the system. Similarly, deserialization is a reverse process when you load or open a file, right. So, this context, maybe later we will try to explain why you need this kind of conversion, but certainly the basic intuition is when you are editing your document, you have a data structure in the system which has pointers. So, when you write it to the system to save it as a file, you need to write those pointer addresses, but those pointer addresses are not going to be available next time you open the file. So, you need to convert them in some form of binary representation, which is best done in terms of an integral type, right. Now, when you do this, you must be careful that your integral type is large enough to fit the pointer address, right. Typically, it is advised that you always choose an integral type which has the same size as of the pointer type. Just as an example, here I show this code I tried in online GDB. So, with So, we can see that I have an integer value, a pointer to an integer and a long value j. And if I look at the size, you will see these are the size, that is the integer is of 4 bytes, whereas the pointer is of 8 bytes, because it is a 64-bit system. And so the long as well as the pointer are of 8 bytes. So, they are compatible, but this is not compatible with int, the size of int. So, the first thing is, if you just try to do an assignment between the integer pointer and the integer and otherwise, you will obviously get errors, because they are not allowed. If you try to now convert the pointer p to I with an explicit cast of int, you will still get an error. Why would you get an error? Because p is of size 8 bytes and I is of size 4 bytes. So, it cannot, and losing this information for a pointer is absolutely critical. It is not like reducing precision only from 2.5 to 2, but it basically you have lost the address. So, this is not allowed. Even the reverse, if you want to do convert an integer value I to an integer pointer by explicit conversion, well, the compiler will allow it to do, but it will give you warning, because the value that you have in I is of 4 bytes and the value that you expect in p is of 8 bytes. So, certainly when you do this conversion, there are 4 bytes of you do not know what kind of values. So, to do this properly, what you can do is you can use the long type in this case. For example, now if you explicitly cast the pointer to integer to long, then the compiler will not say anything, because it is okay, the both have size of 8 bytes. Similarly, the reverse, that is taking a long and casting it to a pointer of integer type, is also okay. So, I mean I took a specific case where the integer and the pointer types are of different size. In your machine, they could be of the same size, in your compiler they could be of the same size. It does not matter what that reality is. All that you will have to ensure is you do this kind of a conversion between an integral type and a pointer only based on the fact that they have equal size. Right? So, this is some of the nuances of conversion in the pointer type, and we close the built-in type rules here. Now, let us look at typecasting between unrelated types, particularly unrelated classes. This is not permitted. That is, if I have just 2 classes A and B, I have 2 objects, I have 2 pointers to these objects, and then I have tried to do all kinds of mixed stuff. That is, assigning the one object to another, not allowed. Trying to explicitly cast it is not allowed, because there is no conversion available. Similarly, the other way, these are not allowed. I try to cast the pointers, they are not allowed. The only thing that is allowed is I can cast the pointer if I explicitly cast it. So, here you can see that I am explicitly casting the address of B, which is of type B star, to the type A star, but it could be very, very risky. So, this is the basic ground rules for unrelated classes. So, what you can do is, certainly as we have done by the explicit casting, we have forced this cast to take place, but this could be really dangerous. So, the same example, we have put some values, it has an integer I, it has a double d. So, we have put respective values, put 2 pointers, and now I print this with p pointer I get the correct value, I print q pointer d, I get the correct value, everything is okay. Now, I make a change. What I do is I take the address of B and cast it to A star and take that value in P. So, P is a type pointer, which is now pointing to a B type object, and similarly that is what I have done for Q. So, what will P pointer I print? P knows, P is declared as A type. So, P knows that P pointer I is an integer. but what you actually have, that you have taken a B object. So, what you actually have there is a floating point value. So, the formats of these two numbers are very different. So, what it prints, it does compile, but it prints garbage. Similarly, it happens the other way, because you are thinking that you are printing a double, but actually there is an int. So, when you do forced casting between unrelated types, be very careful, because it can lead you to really severe errors. We will show what are the proper ways of doing such things. The third set of rules relate to the classes on a hierarchy. If the classes are on a hierarchy, then the casting is permitted in a limited sense. So, I have a class A, which is the base class. I have a class B, which is the derived class. I have pointers to A and B, and I have a void pointer as well. So, this is called upcast. Why upcast? Because I have A and B is a A. So, A is above. So, I am taking from B to A. So, actually PB is pointing to a B object, which has a base which is A, and then whatever additional. So, if I treat this as an A object, then I do not lose any information, because the base part is already there. Only restriction would be that I will deal with the base part. But if I do the reverse, that is, I take a object pointer and think that it is a B object, then I will have serious problem, because the B pointer to B type will expect those additional data of the B class above the base class part, which are not there. So, this will not be permitted. This is called downcast. Now, I can assign any one of them, convert any one of them implicitly to void pointer, which we have seen earlier as well, but the reverse naturally is not allowed. So, we conclude that upcasting is safe. So, if I now take explicit classes A and B with two data members and create, so A has one member, B has an additional member, and of course, it will have the member of A inherited. So, in the A object I set the data A, in the B object I say data A as well as data B, and I create two respective pointers with the addresses. I print through the pointer to A, I print through the pointer to B, I get correct values. If I do this, then on the right hand side I have an address of a B object, and I am taking that to be an A object. So, what I will be able to do is I will be able to print the A part of it, that is this 3. But if I try to print the B part, I will get a compilation error, because P A is of type A class. So, it does not know of a data member which is of type of the data B, which is data B. So, it is actually there, because the address is of a B type object, but I will not be able to access that in this way through because the compiler will not know this time. Now, if I do downcasting forcibly in the same example, the same initialization, all that I am doing a downcasting here. That is, I am taking the address of an A object and putting it as if it is a B object. So, I am leading to information which does not exist. Now, compiler cannot do anything in this case, because you have told the compiler it is an explicit cast, explicit downcast. But with this, with PB, I can access data A, and I think I can access data B also, because it has both of these. It is a PB is a B type pointer. Now, naturally, if I access PA, PB, if I access data A with PB, then I will get this value 2, which is correct. But when I do the other, that actually does not exist, though the pointer thinks that it exists. So, it will be compilation okay, but it will print a garbage. So, you can see that why downcasting is risky, and why it needs to be severely restricted and done only in the proper context. So, to conclude, we have talked about introduce a basic notion of typecasting with particular reference to implicit and explicit typecasting, and different type rules for built-in types, numerical types, pointers, unrelated classes, and introduce the notion of upcast and downcast on a class hierarchy. Thank you very much for your attention, and we will meet in the next module.